Okay, these are questions 1 through 5 that we've worked on last week on Practice EOCT. So if you had a problem with any of those and need some more clarification, good idea to watch this video. Number 1 says, which triangle is congruent to triangle Z by a rotation of 90 degrees clockwise? So I'll put a clock on here. Remember, a clock moves in this direction. So you want to translate this by rotating it 90 degrees. That's like a right angle. So now our triangle is going to look like this. Alright, so that would eliminate choice B and choice C. And you also want to translate it 2 units up. So if it's by the point 76 would be here. So you want to go up. If you look at the first one, this one's lower. So this one's higher. And if you count, it's going to go up 1, 2, 3, 4, 5, 6, 7, 8. So it's translated up 2 units. So the answer choice would be D. Number 2, a series of transformations were applied to triangle PQR to create triangle STU. If triangle PQR and triangle STU are congruent, same size, same shape, which of the following transformations could have been, that's your key words, applied? Well, you definitely could do a reflection, you could definitely do a rotation, and you could definitely do a translation. And most of the time that would make us choose answer choice A. But if we did a dilation and we dilate it by a factor of 2, that would mean we double it. And then we translate it by, or dilate it by a factor of 1/2, that would bring it back to congruent. So it could also be dilation. Be careful with the word could have been. You want to find any instance where it might be congruent. Number 3, for the picture below is triangle ABC congruent to triangle NLM. And I look and I see in the picture, and the marks weren't good on the exam, but I notice I have 2 angles in triangle ABC congruent to 2 angles in triangle NLM. And I also have a side. So I would say those are congruent by angle, angle, side. That's one of our theorems. So I could eliminate answer choice A and answer choice D. If I read answer choice B, it says yes, the measure of 2 sets of corresponding angles, which I have 2 sets of corresponding angles, are equal, and the measure of 1 set of corresponding non-including sides, that would give us angle, angle, side. So the correct answer is B. Number 4, based on the information provided in the picture below, which of the following theorems can be used to show that triangle MNO is congruent to triangle PQR? Now remember, our theorems we used to prove triangles congruent were side, 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 angle, side, angle, side, angle, 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 side, and hypotenuse leg. Those are the only theorems that will prove that triangles are congruent. If I read, I see here that this is an angle mark. This mark is indicating a side, and this final mark is indicating an angle. The side is nodally inside, in between the 2 angles, so that would have to be answer choice B. And number 5, given M and N are parallel and cut by transversal line K, prove angles 4 and 8 are congruent. And here is your proof. The question wants us to justify step 3. So I'll look at step 3, and step 3 says that angle 5 is congruent to 8. So what I do is I'll look at angle 5 and 8. I see angle 5 is here, and I see angle 8 is there. Alright? And I'm looking at my answer choices. Angle 5 and 8 are not corresponding because they don't have the same positions. They are not complementary because they do not add to give you 90. They are not a linear pair because they do not form a line. So the answer choice is D, the vertical angle theorem. And they are vertical angles because vertical angles are always across from each other and they form an X. So that's the first 5. If you need help on the others, find the other video. And good luck on the test Thursday.